Hello everyone, welcome to my session on recursion in C for the course Programming in C. I am JB Katkare from KK Polytechnic, Nasik. These are the contents of the today's presentation related to the recursion in C. Let us start with that how the functions are written. So a normal function is written here for finding a factorial of a positive number. So this type of function is called as iterative function, and these functions are being called from other function. Here is the main as other function, from where there's a call being made to this function factorial n. So normal procedure, this function is being called, it will be executed and return some value. This is how it will be used in normal cases. But the iterative functions are different, written in different way, and what we are going to see are the recursive function written in different way. Before going to write the functions, let us see that what is a recursion. So recursion in programming is a technique that allows you to express the solution of the problem in terms of a problem itself or in terms of themselves, meaning that the solution is containing the contains, so part of it is the way the problem is specified itself. Let us see how it can be interpreted. So we know that the factorial of a number is calculated by the multiplication of all the numbers from 1 to n for n factorial. So in mathematically we write the expression like this, that 5 factorial is written as, so you say 5 factorial is equal to 5 into 4 into 3 into 2 into 1, or 7 factorial is written as multiplication of all numbers from 1 to 7. So in general, n factorial is being specified as n into n minus 1 into n minus 2 into up to 2 or into 1. This is generalization. So to calculate a factorial of a number, let us take example of factorial of 5. So we can specify as a above definition or above description, specify that the problem, the solution is specified in terms of the problem itself. So here our problem is to find a factorial. That is what we are going to find, a factorial of 5. So factorial of 5 is to be found. So to specify the solution for this is 5 into factorial of 4. So factorial of 4 itself is a problem there. So the factorial of 4 can be specified as the 4 into factorial of 3. So that is how we specify that the solution in terms of the problem itself with the smaller scope, or the task is relatively smaller compared to the original problem. Similarly, the 3 factorial can be expressed as 3 into factorial of 2, and the 2 factorial can be specified as 2 into factorial of 1. So at the end we have multiplication of all the numbers from 5 to 1 for factorial of 5. So in general we can write this as the problem as n factorial is equal to n into n minus 1 factorial, or further going at the lowest level. So the generalization of the problem for the factorial of number is given as n factorial is equal to n into n minus 1 for n greater than 1, and n factorial is equal to 1 if n is equal to 0 or n is equal to 1. This is mathematical solution. This is mathematical rule that it should be followed there, that factorial of 0 or factorial of 1 is 1. This is the final solution, we know that. So the recursive functions, when you are going to use in C, it has a form that the functions are going to call itself. In normal iterative function, the functions are executed in continuous sequence of statements, but in recursive function the function will call itself. This is for another different property of the recursive function. So the recursive function, to develop it, we have to think in a different way, or the problem shall be specified in terms of the solution of the problem should be specified in terms of the mechanism, that we say that can we repeat similar process with the other values. That is how we specify here that repeat the process with the steps there. Okay, so in some programming languages like C, if the program allows us to make a call to the function itself, then it is called as a recursion. Few programming language doesn't support the recursion. C supports the recursion, that calling the function from itself. Let us see how the function is written. So here is one function being written, compute, and other is a function main, what we require. So from the main there is a call to the function compute. That what we are written as compute is going to perform some mathematical operations there. So here is a compute there. So when there is a call from this will be executed, and there are local variables for this, like int n is local variable, the parameter k also will become the local variable, and there are some statements which are being executed here. Now at this point in the function compute there is a condition. If the condition is true, then we are going to make a call to the compute function itself with the modified parameter value. So this is called as a recursive call from the function itself. So the execution will not go further, but it will go again to the beginning of the function. So this is called as recursion, calling the function itself from the body of the function. So this is a recursive call, and this recursive call will transfer the control to the start of the function again. So the execution of this will be repeated again and again till there is a recursive call to the function itself. To terminate such a functions, there should be some situation or some instance in which the condition becomes false. This condition should become at least false once for one situation. So when it becomes false, the call will not be made. So what will happen, that the statements s1, s2 up to return n will be executed, but the execution of s1, s2, sn up to return will be slightly different compared to the normal execution of the program. How it will be different, let us see in the next slide how it will be different there. So let us see the factorial here, the function factorial. There is a recursive call to the function which is being written here to call the function itself, and every time the parameter will be modified to n-1. Let us assume that our initial value of n, here the parameter n will be 5, will be working for 5 as the parameter here, initial parameter, and we have the logic which is being developed for recursive function of for finding a factorial. So the problem is specified here, as we have discussed. That problem is specified in terms of the solution. The solution specified in terms of the problem itself, that n factorial is equal to n into n-1 factorial. Now what happens that for the execution of this, so initially when we say n is equal to 5, there is a call from main, or calling function is call from this, and this call will go to the function factorial. So it will start execution of this here. So at the first time n will become 5, as we take an example of 5, and then it will continue. So if you see the execution of this as n is equal to 5, factor will become 1, and n is less than equal to 1, no. So it will go to the else part, and we'll make a call to the factorial again with the new value of n. So from n5, the n-1 will become 4, so the new value of n will be 4, and then we call again from here to the function factorial. So this call is the recursive call for the function. So we are making the call again here. So next time what will happen, that n will be 4. So again the condition is false, we will go to the variation of this factorial equal to, as this is again a call, so new parameter will be 3, next time 2, next time 1. So when it is n is equal to 1, what will happen, this condition will become true. So then when this condition becomes true, the return statement is executed. The return statement will return a value 1, that we know that factorial of 1 is 1, that's why it is written 1. Return should complete the execution of the function factorial, but that doesn't happen. The execution will be slightly different. How it happens now when doing this? So let us see how these things are managed inside the system. So the system has something called as a stack. Okay, stack a memory area. and the stack will hold some values or called as the frames there. Those values will be all local variables for the function we are using. Now let us see, our function is factorial. The local values are n, the parameter, the fact, the variable here, and the value of the function factorial itself is being there. So when we call with 5, this will happen that the frame with the value n is equal to 5, fact is equal to 1, and factorial value unknown is pushed on the stack when we make a recursive call from here. So when I make a call, n will become 4. So next time n will become, the parameter will become 4. So next time the call will be made, n will be 4, factor will be 1 again, and this unknown will go and repeat up to that n will become equal to 1. So in this case n is equal to 1. So n is equal to 1, the return value is 1. So n is 1 here, n is 1. So the return value is n is less than or equal to 1, return is 1. So this return value is the value given here. What we say, that return value is given here. So that is how we are going to write it here, return 1. So the factorial value is written as 1. Now once this is being executed, the return should terminate the program, but doesn't happen accordingly. What happens next is that the remaining statement, so this processing part, this processing multiplication and the value of factorial and assigning it to the fact, will be performed repeatedly for number of times. How many times? The number of times that there is a call to the factorial function, or number of frames which are pushed onto the stack. So these statements are executed repeatedly for the many times, and every time the values of these variables like fact and the value assigned to the factorial will be different. How it will be? Let us see here that there's our function here. So at the end we have terminated that return value with the factorial value as a factor 1. Factorial is 1. So initially the value is 1 for the factorial as the last one. So this is being written. So we will take this one and we will evaluate this. N is equal to 1, factorial is equal to 1, and we get the result as a fact as 1. So we get the result fact as 1. So when we get fact as 1 here, fact as 1, so we return that value. Return that value, it will be here. The return value will be 1 value here there. Okay. So for further execution of these statements here, from these statements, first frame is removed. So what happens that now return value was 1 for the frame below, the n was 2, and factorial of 1 was factorial of n minus 1 was 1. So 1 into 2 is given as a 2 here, which is a return value for calculation for fact, and the return value here, return value will be 2 for the factorial. So again this is repeated, this is not completed yet execution. Another frame is there using fact is equal to 2, n is equal to 3, and fact is equal to 2 will be used there. So we get it that fact is equal to 6, and the return value is 6 for the factorial. So this is repeated for all the frames there. So at the end what will happen, that factorial value return will be 120. So factorial value will be written 120, and this 120 will be written as a final value to the calling function. So this 120 will go back to the calling function here after all the processing components of the recursive function. So this is how the function will be. So how the things will happen here is that, let us see that factorial of 5 again in mathematical way is being specified like this. We know at the end that 1 factorial, we know the result of the 1 factorial, that 1 factorial is written as 1, and from this I can calculate the factorial of 2 as factorial of 2 is 2 into 1 factorial, that is 2 into 1. Similarly I will return the factorial of 2, factorial of 3, factorial of 4 at the backtracking of this using the stack, and we'll get the factorial of 5 as 120. That is the final answer. This is how the execution